Good afternoon, students. Today we'll start our last chapter, that is chapter number 5. The name of the chapter is procedure and macro. In previous chapter, we have seen the procedure type, means we have written one program, that is BCD addition program. In that we have written the procedure. All of you see that the code for BCD addition, in that we have used the procedure and end of procedure. So procedure is nothing but the subroutine that we are calling in our main program execution, and on the priority basis we have to complete the execution of that procedure. So the procedure is mainly used to execute the subroutine program, that is interrupt, we can see that. Procedure is a large program, and it is divided into independent tasks. So for a long coding or long assembly language program, we will break that long program into different types of tasks, which is nothing but the procedure, and we can execute all these tasks one by one on priority basis by giving proper directives and calling instructions. So the procedure is long programs, and it is divided into specific task, independent task, and we can call them to execute on priority basis. So procedure is nothing but the process of splitting a large program into small tasks and design them independently. So for example, that we have seen the program of BCD addition. So in program of BCD addition, we have taken the two numbers and we have added that two numbers, but for BCD valid BCD operation, we have given the decimal adjust accumulator instruction, right? So for that we have written our BCD addition program under procedure, and we have called that procedure with the help of call instruction. So call and return instructions are basically used to write or execute the procedure. So the procedure, now all of you know that the procedure is a splitting of large program into small tasks and designing them independently, and we can call them and execute them in the middle of our main program execution with the help of call and rate instruction, right? So a repeated group of instruction in a program can be organized as a subprogram, or subprogram is also called as a subroutine, and it is also called as a procedure. As I said you, the meaning of all these words, that is subprogram, subroutine and procedure, is same. The procedure is basically a large program splitting into small tasks, and call that tasks independently with the help of call instruction under main program execution, is called as a procedure, right? So what is the advantage of procedure? It reduces the size of main program, it reduces the workload, it reduces the development time, and it uses the modular programming, right? So what are the directives which we have taken for defining procedure and all? Now all of you know that the directive is the keywords which we are using in our program. That means we have defined the data type with the help of directives. Then we'll start and end our segment with the help of directives. So we have used the different directives, common directives, different directives in our programming language. That means DB, DW, or endes, then start, then assume, then CS, DS, endes, all these, end start, all these directives we have used for our common programming. But procedure, for procedure there is different directives are designed. So in that, first directive is a proce means it is a start, it indicates the start of procedure. Then the procedure is of two types, far and near. As I said you, the microprocessor is a multi-programming device, so it is able to do the programming with another peripheral devices with 8086. As I told you or taught you in first chapter, that 8086 doing multi-programming, but it operates in a two modes, that is a maximum mode and minimum mode, right? If it doing the operation inside, means within a processor, then it uses a minimum mode. If processor doing the programming with another peripheral devices, external devices, then it is uses the maximum mode, right? So there is also type of procedure, far and near procedure. So near procedure means if we doing the program under a same segment, in one segment, then it is called as a near procedure. And if we uses the another program, or we are calling the program from another segment or another device, then we are using a far procedure, right? So there is a type of a procedure also. If we want to communicate with another peripheral device, then we'll use the far procedure for programming. And if we are doing the same segment or using the same segment for coding, then we'll use a near procedure. So there are two important types of procedure, that is near procedure and far procedure, right? And then the two instruction, as I said you, two instructions are used to execute the procedure, that is call and rate. We have used the call procedure in BCD addition. So what is a general form? General form is given in notes, that is a proc. We have to write a proc, and we have to define whether it is near or far, or that is not necessary if you are doing near procedure, but you are calling a procedure from another segment or another device, it is necessary to define the segment over there. Now the example is given, add proc near, means we are using the same segment, and we are calling the procedure for addition. And this is the start of procedure, means this directive is used to start out the procedure, that is proc. And if coding is completed for your procedure, then you have to end with end p directive, right? So proc is the start of procedure directive, and end p is the end of procedure directive, right? So here end p, the end p procedure name end p example is given. Then instruction use for procedure is call instruction. It is used to transfer the program control to the procedure by storing the return address on the stack. Then call is also two type, intra segment, and intra segment is near segment, and inter segment is far segment, far call. So there are two types, intra segment means near call, and inter segment means far call, right? So don't confuse between these two. The exam the questions will be asked on these types. So near call indicates the calling the procedure in the same program, and far call indicates the calling procedure from another program. So the difference is given. The near call refers to procedure which is in the same code segment. Far call means it is from different segment. Then near call is also called as a intra segment, far call is called as a inter segment. Near call replaces old IP with new IP, and far call replaces uh, instruction pointer as well as segment, right? So we have to replace the segment also in a far call. Then value of old IP is pushed on stack in near call, and in far call the value of old IP pair pushed in stack, right? So if you want to replace the instruction pointer, then in far call you have to replace with the segment also, right? So whenever you want to replace or push the contents of pointer, you have to replace all the contents of your segment also, right? So there should be always replacing with the pair and pointer and segment pair. So in near call you have to push and replace the pointers contents only. There is no requirement to replace the contents of segment because it is in the same segment, right? Then less stack location are required in near call, and more stack locations are required in far call because we are replacing segments. So these are the some important parameters about near and far call. Then ret instruction is a return instruction. We have used this instruction in BCD addition. This instruction is used to returning from the procedure. It is used to transfer the program control from the procedure back to the main program. Then it is used to return from program, and there are also two types: near rate, which is in the inter segment, and far which is in the intra segment, and far it is in the intra segment, right? So then again there is a parameter passing when we use near and far procedure. So passing through register, passing through another stack, this is shown in the figure. So the passing parameter through the register, the diagram is shown in your notes. The calling procedure can pass up to 6 parameters to the called procedure by using general purpose register, that is SP and BP, stack pointer, base pointer. The called procedure can likewise pass the parameters back to calling program through the general purpose register. See, the procedure, under procedure one code is given written where the register AX is used, and we have called the procedure 2. So when we call the procedure 2, the parameters from general purpose register is transferred towards the procedure 2. Then it will execute the program. General purpose register takes the parameters, do the procedure, and again passing the parameters towards the procedure, and procedure will display the parameters using general purpose register only. So this is called as a parameter passing using general purpose register. Then parameter passing using stack is also shown in your notes. In that, see the procedure, the push number program is written, then we have called the procedure 2. Then the parameter is passed to the stack, and from the stack again it is passed to the procedure, which is called as a passing parameter through the stack, in which we are increasing the stack pointer parameters. Then passing the parameters in argument list means we have written the procedure, then we have written the program, then it is then call procedure 2 is written, means the parameter is passed towards the segment. In segment the parameters taken and it is again passed to the procedure is called as a passing parameters through argument list, right? So these are the some parameters in which you can see that how the program execution controls transfer from one point to another point with the help of procedure. Then here the program for BCD addition using procedure is given. In that you can see that in data segment number 1, number 2 is defined. Then we have to take the BCD sum, which is unknown. Here data segment we have ended after that. Then code segment is written. In that assume sentence, common sentence is written. Then move dx comma data, move ds comma dx, initialization is done. Then we have call BCD addition program, and after that we have terminated the program with the help of two instruction: move h comma 4ch int 21h, right? So we have just call that procedure with the help of instruction call BCD underscore add, and we have terminated program using move and int instruction. And in that below that we have written the procedure, that is BCD add proc, means we have written or started the BCD addition program, small program. In that we have moved first number into x, second number into bx, and we have added that both numbers. After that from accumulator we have taken the result and we have stored into BCD underscore sum. And here we have ended our procedure with BCD underscore add end p and return, means after execution of this program, the it will goes to main program. So this is the example of procedure program for BCD addition using procedure. We have done this program and we have seen the output of this program. You can also check once again by using this code. Then what is a macros? Means if we want to perform any equation or we can say that if you want to perform arithmetic operations by using some long equations, so for that long equation you can define a symbol with the help of macros, right? So small sequence of codes of the same pattern are repeated frequently at different places which performs the same operation on different data of the same data type. Such repeated code is called as a macro, or it is called as an open subroutine. Then the process of defining macros and using them to simply programming process is known as a macro programming. Then advantages, it reduces the amount of repetitive code, it reduces the error, it reduces execution time and simplify the program. If we want to use macro in our program, you have to define it first. A macro definition must be written before only segment in a program. The assembler directive, micro directive, endem directive is used. So likewise procedure, there are some directives used for macro. The directive used for macro is given, that is macro, endem, local, include and purge. In that macro is directive which informs the assembler to beginning of the macro. General form is given. The difference between macro and procedure is that a call to macro will be replaced with its body during assembly time, whereas call procedure will be explicit transfer of program control to the procedure during runtime. Then endem is informs the assembler to end of macro. General form is given. Then local, it is used to define the data item and instruction label within the macro definition. If we have used more than one macro in program, then local directive is used to define the local variable. Then include, this directive informs the assembler to include the statement defined in the include file, and the general form is given. Then purge is another macro directive. It is enables you to delete the unwanted macro used in the program. Then procedure types, there are some important procedure type: re-entrant procedure and recursive procedure. In exam there is always questions will be asked in this topic, re-entrant and recursive procedure. So what is a re-entrant procedure? The example is given with the help of diagram. This type of procedure, all data must be pushed from register to stack. So see, main program call BCD addition means call BCD addition we have used the register, and from register we have used the pointer. So in this procedure, that means re-entrant procedure, the parameters is passed from register to stack. And in recursive procedure, in this procedure it is called as a recursive because it's called within itself, and it is used with work with complex data. Means it uses the same segment, you can say that. So there is a difference given between re-entrant and recursive procedure. The procedure which can be interrupted, used and re-entrant without losing or writing over anything is called as a re-entrant. And recursive means it is the procedure which calls itself. A re-entrant means the flow of control could be interrupted by hardware interrupt, and in recursive the flow of control is caused by call instruction and transferred to the user procedure. So these are the important types of procedure. Then the difference between procedure and macro is given. Once again we can recall. So procedure is a set of program statements which can be processed independently and reused again and again. Macro is a set of program statements, that small program statement that can be reused again and again. Procedure is loaded in the main program only in once. Macro can be loaded into main program wherever used. Less memory required in procedure, more memory required in macro. Call and read instructions are used in procedure. Call and read instructions are not used in macro. Include and purge instructions are not used. Include and purge instructions are used in macro. So here we have ended with our chapter 5. It is very simple. Just go through notes once again, and I will give you the assignment. Solve it and upload it on a given link. Thank you.